We have more nutrition science than ever before. More diets, more supplements, more expert opinions, more studies than at any point in human history. We can break food down into molecules, isolate nutrients, design synthetic vitamins, even build complete lab diets that meet every requirement of the human body. On paper, this should be the healthiest generation in history. But something doesn't add up. People are more tired than ever. Digestive issues are now normal, and low energy isn't rare anymore. It's expected. So here's the real question. If we understand food better than any generation, why are we getting worse? There are only two answers. Either we're still missing something essential, or we removed something we didn't realize we depended on. But what if the answer isn't another nutrient? Not protein, not fat, not vitamins, not minerals. Something else. Something invisible. Something no label shows. Something no diet tracks. Something that cannot be measured. Time. Because every food in this video has one hidden ingredient. Not what it is, but what it becomes. And how long it is allowed to become it. Across cultures, continents, centuries, one category of food keeps reappearing.
Not fast food, not instant food, but transformation food. Food that only becomes something else through waiting. And that raises a question most people never ask. Why did humans learn to trust decay? Because everywhere else in life, change means danger. Spoilage means risk. Rot means rejection. But in food, change became survival. And at some point in history, we discovered something deeper. That time itself can improve food. Not just flavor, not just preservation, but function. Because as food transforms, microorganisms begin to break things down, pre-digest compounds, create new molecules that weren't there before. And those changes don't just affect the food, they affect the body consuming it. Gut bacteria shift, digestion becomes easier, nutrient absorption improves. And once that idea appears, food stops being static. It becomes something still becoming, something still interacting with your biology, even after you eat it. Let's start with something simple. Number 1, fermented cabbage, made from just 3 things: cabbage, salt, and thyme.
No heat, no cooking, no machines, no real control, just natural biology, left alone long enough to change itself. At first glance, it looks wrong, even unsafe, because everything we're taught says food should be fresh, clean, and stable. But this breaks that rule completely, because what looks like decay is actually controlled microbial transformation. And during that transformation, something important happens. Naturally occurring bacteria begin to multiply. They start breaking down plant fibers. They produce organic acids. And in the process, they create compounds that support digestion, compounds that interact with your gut microbiome. Now here's where it gets interesting. Timing changes everything. Stop it too early, and it's sharp, raw, unfinished. Leave it too long, and it becomes overly sour, almost aggressive. But somewhere in between, something subtle happens. The cabbage becomes easier to digest, certain nutrients become more available, and beneficial bacteria reach a peak balance. So now you're forced into a question humanity never solved. When does decay become nutrition? Because there is no visible boundary, no timer, no warning, just invisible biological change happening beneath the surface. And here's the shock.
Ancient cultures created this without knowing bacteria existed. No microscopes, no microbiology, no explanation. And yet somehow, they consistently produced food that didn't just last longer, but often supported digestion better than its raw form. So was it luck? Or something else? Maybe repetition so consistent, it became knowledge without science. Because this process doesn't require understanding, it only requires time. And time doesn't just preserve food, it transforms how the body interacts with it, breaking down compounds that are harder to digest, reducing certain natural plant defenses, and creating new byproducts that weren't there at the beginning. And that changes something fundamental, because now food isn't just feeding you, it's interacting with your internal system, your gut, your microbes, your metabolism. Now we go deeper, because fermented cabbage is only the beginning. What comes next isn't just food changing, it's food behaving like a system, not metaphorically, but biologically, structurally, alive, in motion. And once you see it that way, you stop thinking in recipes entirely. You start thinking in ecosystems. And that changes everything. Kimchi looks like a recipe, but it behaves like a living ecosystem. Cabbage provides structure. Garlic influences microbial direction. Chili reshapes biochemical activity. Salt controls the speed and pathway of fermentation. But here's the detail most people miss. Nothing in kimchi happens instantly. Nothing exists in real time. Everything depends on one invisible variable, time under changing biological conditions. And during that time, something important happens. Naturally occurring bacteria begin to multiply. They produce organic acids. They reshape the structure of the vegetables. But from a health perspective, that transformation matters even more, because fermentation begins breaking down complex compounds into simpler ones the body can process more efficiently. This can support digestion by reducing the burden on the gut. It also interacts with the gut microbiome, the system now linked to everything from metabolism to mood regulation. And here's where it becomes even more interesting. Emerging nutrition research connects fermented foods with improved metabolic response patterns, including how the body manages post-meal blood sugar levels. Not by acting like medicine, but by changing how food is processed before digestion even finishes. Now here's where it becomes interesting again. Kimchi didn't emerge from one origin point. It appeared across different regions, different climates, different ingredients. Yet the same pattern kept repeating. Vegetables left in controlled salt environments begin transforming into something entirely new. So the question becomes unavoidable.
How did separate cultures discover the same biological process without ever knowing microbiology existed? Even more interesting, why does kimchi still work even when conditions are slightly different every time? Because fermentation is not fixed, it is adaptive. It responds to temperature, it responds to humidity, it responds to microbial environment, it responds to time itself. And that adaptability is exactly why its effects on the body are also dynamic. Gut bacteria diversity can shift. Digestive efficiency can change. Even how the body responds to carbohydrates in a meal can be influenced indirectly through microbial balance. So kimchi is not a recipe. It is a biological timeline. And what you eat is not the process itself. It is a snapshot of that timeline. A frozen moment inside a transformation that is still unfolding. And that should change how you see food entirely, because you are not consuming something static. You are interacting with a system that has already begun reshaping how your body processes energy. Now, kimchi still feels familiar. Vegetables, salt, spice, even if it's complex, it still feels like food. Now, that feeling is about to break, because we're no longer talking about vegetables changing. We're talking about milk becoming something entirely new, something that behaves less like food and more like a living system.
Kefir is not food in the traditional sense. It behaves like a living ecosystem. Clusters of bacteria and yeast form a self-sustaining microbial community. And when introduced into milk, they don't simply ferment it, they restructure it. Proteins break down and reform. Sugars convert into new biochemical compounds. Texture shifts continuously over time. Flavor evolves depending on duration and environment. But here's what matters from a health perspective. These transformations don't just change taste, they change how the body handles the food. Some components become easier to digest. Certain milk sugars are reduced during fermentation, and the resulting structure interacts more gently with the digestive system compared to unfermented milk in many individuals. This is also where fermentation connects to metabolism, because when digestion becomes less stressful on the gut, downstream systems like energy regulation and appetite signaling can respond differently. That includes pathways linked to blood sugar response after meals, not by directly controlling glucose, but by altering how food is broken down and absorbed. But here's the fragile part. If even one condition changes, temperature, timing, surrounding microbes, the entire system behaves differently. So what does that mean? It means kefir is not made, it is hosted. You are not creating it, you are maintaining conditions for a living biological process to unfold. And this leads to a more uncomfortable realization. If food behaves like something alive, then food is not just matter, it is process.
Something ongoing. Something never fully complete. Something that interacts not just with digestion, but with metabolic systems tied to energy, inflammation balance, and long-term cardiovascular function. Something you temporarily participate in, but never fully control. Kombucha. It starts simple. Tea, sugar, water. Nothing unusual, nothing special. But leave it long enough, and everything begins to change. Sugars break down, acids form, microbial activity reshapes the liquid itself. And during that process, the drink's chemical profile changes completely. That includes acidity levels, organic compounds, and how the body responds to it after consumption. Which is why fermentation is often discussed in relation to digestion and metabolic balance, because the food entering the system is already partially transformed. But here's the key idea. Timing defines identity. Too early, it's just sweet tea. Too late, it becomes sharp, acidic, unstable. So here's the question that breaks intuition. When does kombucha stop being tea? And why is that answer never the same twice? Because kombucha is not stable. It is a moving transformation window.
Every batch shifts slightly, even when the ingredients are identical. And that means something important. The way your body processes it is never completely identical either. Because fermentation introduces variability into what would otherwise be a uniform input, which leads to a deeper realization. Consistency is not natural, it is engineered. Nature does not guarantee repeatability, it guarantees change. And fermentation simply reveals that more clearly than anything else. Now something subtle begins to shift. Because so far, everything still feels familiar. Vegetables, milk, tea. Even when they transform, we still recognize what they started as. But now we cross a line, because the next examples reveal something deeper. Food does not have a fixed identity. It only has a temporary state. And that state doesn't just affect taste, it affects how the entire body responds to it. Number 5, traditional yogurt. Real yogurt is simple. Milk, natural fermentation. That's it. No engineering, no stabilizers, no standardization. Just time interacting with biology.
But from a health perspective, that interaction matters deeply. Because fermentation begins breaking down lactose and milk proteins into simpler compounds, which is why traditional yogurt is often easier to digest than milk for many people. And this connects directly to gut function, because the gut microbiome doesn't just respond to what you eat, it responds to how food has already been transformed before it arrives. Now, most people miss something important. Traditional yogurt was never identical. Every batch changed slightly, sometimes thicker, sometimes tangier, sometimes softer, because fermentation is not controlled by one variable. It is shaped by environment, temperature, microbial presence, timing, even surrounding air. And those variations also change its biological impact. Some batches may be gentler on digestion, some may influence gut bacteria differently, some may slightly alter how the body processes nutrients afterward. Now compare that to modern yogurt. It is standardized, engineered, predictable, identical every time. Same taste, same texture, same result. And that raises a deeper question. Did we improve yogurt or remove what made it alive? Because stability feels safe. But from a biological perspective,
Systems that never change often lose interaction depth with the body.
And that matters because digestion, metabolism, and even energy regulation all respond to variability in food inputs over time. Because everything so far has still been soft transformation: milk, tea, vegetables. But now we move into something harder, something structural, something most people think of as finished food, but isn't. It is still changing long before heat ever touches it. Number 6. Sourdough bread, core health transformation. Now this is the turning point. Sourdough is not just bread. It is time made edible. Most modern bread is fast. Instant yeast, quick rise, predictable structure, manufactured consistency. It is designed for speed, not transformation. And from a health perspective, that speed matters. Because faster fermentation means less breakdown of complex starches and compounds before digestion begins. But sourdough is different. Wild yeast and bacteria begin breaking down flour long before baking even starts. Which means something critical. Transformation begins before heat is ever applied. Before shaping, before baking, before it even looks like bread. And during that time, something important happens biologically. Some starch structures are partially broken down. Gluten structure is modified over time. And fermentation produces organic acids that alter how the body processes the bread afterward.
Which is why sourdough is often discussed in relation to digestion and post-meal response differences compared to standard bread. So now the question changes completely. Where does sourdough actually begin? When it enters the oven? Or when microbial activity starts reshaping it hours or even days earlier? Because sourdough is not a single moment, it is a timeline, a living sequence of biological events unfolding over time. And the oven is not creation, it is completion. Everything important has already happened before you ever see it. Now think about what that means. You are not eating flour anymore. You are eating transformed flour. Flour that has already been partially broken down by time and microbial activity, which can influence how quickly it is processed in the digestive system and how smoothly nutrients are released into metabolism. And here's the fascinating part. Humans were making this long before they understood microbiology. No explanation, no scientific language, just observation repeated across generations. And what they noticed was simple. Bread that was allowed to change was easier to digest, more stable after eating, more satisfying, without ever knowing why. And that raises a deeper question. How many things did humans get right without ever understanding them? Because sourdough quietly reveals something fundamental.
Food is not defined by what it starts as. It is defined by how long it is allowed to become something else, and that becoming directly affects how the body processes it. Now the idea shifts again, because everything so far has still been transformation within food we recognize. Milk becomes yogurt, tea becomes kombucha, flour becomes bread. But now we reach something deeper. What if time doesn't just change food? What if it improves how the body interacts with it? Number 7. Miso, long-term metabolic food. Miso is fermented soybean paste. Simple ingredients: soybeans, salt, thyme. But here's what makes it strange. The real ingredient is not listed anywhere, because miso is not made quickly. It takes months, sometimes years, just to become what it is. And during that time, fermentation breaks down soy proteins and complex compounds into forms that are easier for the body to utilize. Which is why fermented soy foods are often associated in nutrition discussions with improved digestibility compared to raw soy. But it is not just digestion. Fermented foods like miso also interact with gut bacteria in ways that influence metabolic signaling in the body over time. Not instantly, not dramatically, but gradually through repeated dietary exposure. And yet,
it is not rare. It is not luxury. It is not experimental. It is everyday food, used in soups, used in meals, consumed regularly without hesitation. Now think about that contradiction. If something takes years to form, why is it eaten daily? Because ancient food systems did not separate time into categories like we do. There was no fast food versus slow food mentality. Everything already contained time. Everything assumed transformation. And miso reflects that philosophy biologically too. Because what your body receives is not just soybeans anymore. It is a pre-transformed form of nutrition shaped over time. And that changes how efficiently the body processes it. We didn't lose recipes. We lost the patience that made those recipes possible. Number 8, aged cheese, metabolic complexity food. Most food decays. Cheese evolves. That difference changes everything. Inside aged cheese, proteins break down slowly. Fats transform. Enzymes reshape structure. New compounds form that didn't exist at the beginning. So instead of losing value over time, it gains complexity. And from a biological perspective, that breakdown process also changes how nutrients are delivered to the body. Smaller compounds can be easier to process during digestion, and fermentation products can influence how the gut and metabolism respond after consumption.
So instead of becoming less useful over time, it becomes structurally different in how it is handled by the body. And here's the paradox. Why does decay sometimes improve food? Because in most systems, time equals loss, freshness equals value, expiration equals decline. But in fermentation systems, time equals transformation. And transformation can change how the body responds to food entirely. So aged cheese challenges a core assumption that older means worse. Because here, older means biologically different, more complex, more broken down in ways that change digestion and nutrient release. Now, think about what that means. If time can improve what we eat, then maybe time was never the enemy of nutrition. Maybe it was part of how food interacts with the body all along. And that leads to a question we rarely ask. If we control everything to prevent change, what are we actually removing from the biological equation? Because aged cheese suggests something important. Some foods only become fully usable by the body because we waited long enough to let them change. Natto. Natto is one of the most divisive foods in the world. Fermented soybeans. Strong smell. Sticky, elastic texture. A form that immediately feels unfamiliar. For many people, the reaction is instant, not curiosity. Rejection. Before logic even enters the process. But scientifically, natto is not random. It is controlled fermentation, producing measurable biochemical change. During that process, soy proteins are broken down into smaller compounds. Vitamin K2 is naturally formed through bacterial activity, and the structure of the food becomes completely different from raw soy. Now, from a biological perspective, that matters, because fermented compounds can interact differently with digestion compared to unprocessed forms. And vitamin K2 is often discussed in relation to cardiovascular function and calcium metabolism in the body. So now there is a contradiction. Instinct says avoid this, but biology says this is deep transformation. So which is correct? The uncomfortable answer is both, but they operate on different timelines. Number 10. Fermented garlic and honey. This sounds simple. Garlic, honey, two stable ingredients. Nothing unusual. Both naturally long-lasting on their own.
So when combined, you expect stability, but something begins to shift. Not immediately, not dramatically, but almost invisibly. The garlic softens, the honey thins. Slow enzymatic and microbial interactions begin inside the jar, and from a biochemical perspective, natural compounds slowly reorganize over time. This is not rapid fermentation, it is slow transformation, a system that continues adjusting itself based on time, temperature, and internal enzymatic activity. And eventually, it is no longer garlic. It is no longer honey. It becomes something entirely new, not a mixture, a transformation product created only because time was allowed to act uninterrupted. The more we remove time from food, the more we may be removing what food actually is. Because human biology didn't evolve on instant systems. It evolved on transformation, on microbial change, on slow breakdown and rebuilding, on decay turning into nutrition instead of loss.
Here's the uncomfortable possibility. We didn't just speed up food. We may have removed its transformation layer. And if that's even partially true, then modern nutrition isn't just incomplete, it's missing an entire dimension. So I'll leave you with one question. What surprised you more? That food changes over time? Or that we stopped letting it? If you want more deep breakdowns like this, subscribe, because this is only the beginning.